thrash those matters out. So there's this whole thing about a lack of connection between science and religion. Can they get along? Is there a place for them somewhere to meet up? And Herman Wouk wrote this book. I actually had forgotten about Herman Wouk. I had read one of his books. I mean, the last time I read a book by him was years and years ago, that I picked up in the United States, I think. And I saw this book in Geneva 2 years ago in a bookshop. So The Language God Talks. I was attracted to the title because there's another, I'll tell you, there's another book by Francis Collins called The Language of God. And Francis Collins is an excellent scientist who one of the people who mapped the human genome. And he was President Obama's and is Trump's scientific advisor, and he is the head of the NIH. And he wrote The Language of God. This is the language God talks. And I opened the book, and I'll tell you why I became excited about it. So Wouk was born in 1915, so this year he'll be 103 years old. So that should tell you something about Wouk. Here's he in his religious attire. Right. So this is the other book, The Language of God, and this is Francis Collins, but I'm not going to talk about him today. So the works of Herman Wouk, mainly books on the war, The Caine Mutiny, The Winds of War, War and Remembrance. And Henry Kissinger once said, it's not just a book, it's the war itself. When Wouk writes, he really writes well about wars. Now, Wouk knew that scientific knowledge played a huge role in the war, because of the atom bomb that they made. So he knew nothing about the bomb. He fought in the war, but he admits total indifference to the bombing of Japan. So what he said is he had a new project. I want to throw a rope around the whole global war, but I know nothing about science. I don't know how they made the atom bomb. I don't know any physics. So he spoke to a few people, and they said the place to go would be Caltech, the California Institute of Technology. And but they warned him, don't try and see Richard Feynman. How many of you have heard of Richard Feynman? Yeah. So they warned him, don't see Richard Feynman, because Feynman has had a reputation of being rather arrogant. Okay, so Wouk did Poor Man. He goes and meets Murray Gell-Mann, the other Nobel laureate at Caltech. And Murray Gell-Mann is probably the most arrogant sort of physicist on earth. And there is a fabulous, fabulous biography of him called Strange Beauty. And he said to Wouk, the gap between a person who understood quantum mechanics and one who did not was arguably wider than the difference between a human being and a great ape. And Wouk said to him, well, in Talmudic discourse, this would be a standoff of the sages. He wrote The Quark and the Jaguar because he was the first physicist to describe the quark. And the quark is a basic component of the protons and neutrons in the nuclei of atoms. So those things are made up of quarks. And then he wrote The Quark and the Jaguar, showing how you link something so basic like a quark to a magnificent South American cat, the jaguar, in the jungle. But Wouk decided very quickly, he's not worth talking to. I sort of have now a sympathy for Murray Gell-Mann, because I think he's had a hard life with Feynman, but he's also had a hard life as a child. He came from a very poor Jewish family, and he worked his way up because he was absolutely brilliant. So this is Murray Gell-Mann and Feynman. They both won the Nobel Prize at different times, and every time somebody discusses this about these arch rivals, they ask who was more brilliant, which is, I think, a bit of a stupid question. Right. Now, so Wouk said, Gell-Mann, you can go. I don't need to talk to you. I'll go to Steven Weinberg. Now, Steven Weinberg is another Nobel laureate, a physicist, okay, who wrote The First 3 Minutes about the Big Bang, what could have happened. And he is credited with this statement, which became one of the most famous in modern physics. The more the universe seems comprehensible, the the more it also seems pointless. The effort to understand the universe is one of the very few things that lifts human life a little above the level of farce and gives it some of the grace of tragedy. I mean, he has irritated so many people, but he is quoted in so many areas with this. And the other point he made is one of the great achievements of science has been, if not to make it impossible for intelligent people to be religious, then at least to make it possible for them not to be religious. We should not retreat from this accomplishment. Now, imagine saying that to Herman Wouk, a religious man. So, Wouk is intrigued by Weinberg because Wouk actually liked Weinberg. His reaction to Weinberg was not similar to his reaction to Murray Gell-Mann. But Wouk is intrigued and he says, you know, the baby's order and purpose begins at the comforting nipple. And there's order there. There's something there. Weinberg's ends at the bafflement, at the wondrous order he sees in the universe, and despair at the comfortless absence of purpose. How can this be? How can this be amongst the human race? But Weinberg cannot answer why he feels the way he feels. Anyway, he meets Richard Feynman, and the first line of this brilliant book, that's why I bought it. I opened the first page, it says, "More years ago than I care to reckon up, I met Richard Feynman." And I was immediately taken. So I bought the book, and I read the book, and I'm discussing it with you today. I'm sharing it with you. Now, Richard Feynman is famous for this statement. He was asked one day, he said, somebody said to him, Feynman, if you were told that this universe is going to end in the next 5 minutes, what would you say is the greatest accomplishment of humankind? And Feynman says, the fact that we discovered that all matter is made of atoms. Can you believe that? That is how powerful that statement is. That everything, and I said this yesterday, everything is made of atoms. So, all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. In this one sentence, you will see there is an enormous amount of information about the world, if just a little imagination and thinking are applied. I wish he had actually told me this when I was in school. But he warned Wouk, nobody understands quantum mechanics. Now here's Wouk. Wouk wants to learn some science. So he meets Richard Feynman, and Richard Feynman starts a conversation with him, and it's the beginning of a kind of friendship. Okay, so this is the atom. I've just taken a few sort of models of how we understand it to be. It's not necessarily so, because it gets very complicated as we go along. But in school, and perhaps even at first-year university, they talk about, atoms having nuclei and then electrons orbiting the nucleus, just as our planets orbit the sun. And then you can have more electrons, and as electrons fill these energy levels that they're moving around into, you have more energy levels, okay? So the electron was discovered by J.J. Thomson in 1897, the proton in 1918, and the neutron in 1932, right? And you know what's the strangest thing is, part of this whole atomic theory, they always tell you that an electron need not stick to its own energy level. It can jump to a higher one, or it could come down to a lower one. And this is the biggest surprise for the quantum physicists, is there is no cause for that. So at this micro level of the universe, we don't speak of cause and effect. Things just happen. We speak in terms of probabilities. Anyway, this business about fine-tuning of sizes and ratios, there's a particular ratio of, say, the size of a proton in relation to an electron. Now, this fine-tuning has been picked up by people who are actually studying science and religion and saying, do you know that if any of these proportions were slightly different, if the universe was 1 degree hotter at the beginning when the Big Bang took place, we wouldn't have been here. And that's possibly true. So there's this whole thing of, then why did it happen? Why did it happen? Who fine-tuned these constants? People say it's God, people say it just happened. But as we go along, we will look into it. If we have time, we'll discuss Stephen Hawking's views on that. Anyway, Niels Bohr, who won the Nobel Prize for Physics in 1922, a Danish physicist, he said that the binding energy for each electron existed as discrete packets, or quanta. So electrons could occupy only certain stable states as they orbited the nucleus at different radii. Therefore, matter is stable. And he was a physicist, so he made that contribution to physics. Now, the number of electrons in the successive orbits here, if you look at these orbits, particularly the outer ones, give the elements their characteristic properties. It is the outer ones that are involved in chemical reactions as we know them, and that's chemistry. So what Bohr has done with these statements is he has connected physics and chemistry, one of the most riveting and important unifications in science, and I said, what a connection, because we are discussing interconnectedness. Now, so Wook and Feynman start chatting with each other. So Herman Wook says to Feynman, I want to throw a rope around the whole global war. And Feynman says, well, that's the sort of thing genius reaches out for, which is he gave Wook a compliment. But Feynman also says, but you want to know about the bomb, because you want to include it in your book. Creating the bomb was not a scientific breakthrough. This is what Feynman said. And he worked at Los Alamos. And he was one of the contributors. He was one of the brains behind the making of the bomb. And he also warned Wook, while you're talking, you're not learning anything. So you should be thinking all the time. Okay. So Wook said, and I was avid to learn everything I could from this man. Okay. So one day, now this is just an example of how these conversations went. Wook says to him, you know, my book, The Winds of War, has had a critical reception. And Feynman was actually sympathetic. He said, but a man needs the praise of his peers, right? And then he changed the whole topic. He said, have you heard of the classical two-slit experiment? Now, what Wook is trying to do is, he's trying to get an idea of using Feynman's scientific knowledge to include in a book, but he's looking at the whole thing partly from a spiritual or religious point of view. And Feynman keeps coming back to him and responding to him about science. So, now this two-slit experiment Feynman calls one of the greatest experiments in quantum mechanics. I'm not going to actually explain it, but I just want to tell you that over here, can you see that? If you pass light through one hole in a screen, and it hits another screen in which there are two holes, right? So that light starts there, and then the light waves pass through these two holes, and then there's an overlap and an interference, and eventually there is a shield which actually receives this in this form, and you get this pattern of dark and light bands. The interesting thing about this experiment is it gave them an insight into quantum theory. It gave them an insight into what happens at the level of basic particles in this universe. Because if you pass just one photon, it could go through that hole, it could go through that hole, or it could go through both holes. And they came to realize that a photon can be here and there at the same time in another galaxy or another universe. And for the photon, there is no time. T is equal to 0. And when they realize this, they realize that this whole thing only leads to this explanation of light being both particulate and waves. And it's, as I said yesterday, it's counterintuitive. It's very hard to actually imagine, and it could only have come from the brains that these physicists had. But for me, the problem is that all this happens at that micro level of in the subatomic world, and yet the big world, as we see it, carries on a daily basis. And you can't link the two. But if you want to read about it, here's an excellent book by John Gribben called Schrodinger's Kittens. And it's by Weidenfeld and Nicholson who actually published it. Now, Wook says, why are scientists so overconfident? Why are they so sure about their science? Is it because science has peer review, a controlling structure of eminent equals, who police the work and integrity and merit of each other and of new work as it is published? Or is this the last and final word that makes science superior to all other attempts at describing reality? When you read this book, you'll find that Wook is irritated. He's admiring of science, but he's also irritated by scientists and the overconfidence. So he says they shouldn't be so sure. And he says, look, the world begins for a baby as a big blooming, buzzing confusion. And he got it from William James, who wrote, I think, The Varieties of Religious Experience. The baby has to sort out the confusion of the world all by himself. But at the beginning, he has a vague sense of order in things, such as the nearby warm nipple when he's hungry. Now, when he can walk and talk, he is going to ask his parents, or she's going to ask her parents, why am I here? Where did I come from? And Wook says, that's when the fun starts. What do these scientists tell their children? So the religious people will tell the children, God gave you to us, or the stork brought you, whatever. The scientists will say, daddy's penis ejaculated sperm and mummy's vagina sent the sperm up to the ovum and we made you. But he says at the end of the day, he tells the scientists, you don't know why. You don't really know why. So don't be too sure that you know everything and that your science is going to tell you everything. Because of all the stunning advances in modern science, cosmology and biology, we still don't know the answer. Faith is hope, not fact. But never mind, he says. Feynman sees the world as the product only of atoms and the void. And for all that he finds that world fantastically marvelous, and Wook actually grants him that admiration for finding the world fantastically marvelous. So they share something. The difference is Wook says it was made by a creator. Feynman says there was no cause to the universe. Okay. So he turns around to Wook one day during one of their walks and he says, do you know what language God talks? Calculus. Wook says, just as I did not know calculus, Feynman had no knowledge of fiction. But Feynman was not interested in fiction. Feynman said, why read fiction when the real thing is so interesting? It's a similar thing that Richard Dawkins said. He worked in San Francisco as a postdoctoral in the 60s when the hippie movement started. And he said, why did they have to take all this stuff to get a high? I just look at what I'm doing in my laboratory and I get a high. So, there's different sort of approaches to the world. But Feynman's position is in this statement. He says, it doesn't seem to me, this is what he says to Wook, it doesn't seem to me that this fantastically marvelous universe, this tremendous range of time and space and different kinds of animals, and all the different planets, and all these atoms with all their motions and so on, all this complicated thing can merely be a stage so that God can watch human beings struggle for good and evil, which is the view that religion has. The stage is too big for the drama. And I think this is what set Wook off to write this book. Because Wook says, is the stage really too big for the drama? And that is the main theme of the book. At the outset, let us take a fresh look at the stage and start with a grand moment in the drama. So, first he asks Feynman, and does this partly answer your question? Was this big stage that you're talking about, which took billions and billions of years of time, with its long and deep time, its energy and mass, its galaxies and solar systems, its order and tendency to disorder, its expansion, wasn't that all that necessary for the development of living things of life? We appeared in this universe. Perhaps these conditions and the amount of time was needed to make us complex human beings. I don't think Feynman was very impressed with that. Okay, so Wook saw two dramas. the humanist drama, the Adam and Eve and the story of creation, and modern science, the study of nature. So Wook said, let me look. You see, he had to now actually do an exploration himself. Let me venture into Feynman's big stage. And he reads about the Sputnik that the Russians sent out in 1957, the first man-made space satellite. Then Yuri Gagarin went up in 1961. And the Russians were way ahead of the Americans, right? And they even had a space station called Mir and a reusable spacecraft called Soyuz. And I've seen pictures of this, and they look like bathtubs, how they actually went around the Earth, heaven knows. Okay. And then JFK comes along, because now there is this competition. I believe we should go to the moon. They want to beat the Russians. So Apollo 11 on the 16th of July 1969, there were 6 missions. And Wook says when they went to the moon, Homo sapiens had made a spectacular debut on Richard Feynman's big stage with a leap between 2 celestial bodies. Wook decided to talk to Neil Armstrong, the first man on the moon, and said, I want to write about you and your first experience and how you felt when you actually took that one small step for yourself, but a big step for mankind. And Armstrong turns down Wook's offer to help write his story. He just said it was a team effort and my personal feelings in this don't matter. Wook had a hard time. Okay, then there were the Voyager travels. 20th of August 1977, Voyager 2 went to Saturn. 2 weeks later, Voyager 1 went to Jupiter. So Voyager 1 took a picture of Earth, and it was described as that pale blue dot. It was the first ever picture of Earth. Of all the planets, Earth has the most diverse collection of rock. Most remarkably, these diverse raw materials that make our planet's surface so unique have come together to create this astonishing thing. I'm using the language of Thomas Nagel, the philosopher, this astonishing thing called life. These robot probes have been wowing the world with gorgeous close-ups, right, of Jupiter, its red spot, its moons, and now more recently, I'll come to that now. So, the program the Americans had was an origins program. Where are we from? Are we alone in this universe? Has Earth-like planets circling Mars, Pathfinder 1 and 2 that they sent up, and there are traces of water on Mars, right? And there's elusive hints of conditions that were possible for the appearance of life. And this has religious implications. I think I was reading one time the English Sunday Times. It said, well, what if they found life on Mars? Would there be another Jesus Christ there or Muhammad there? Would it be similar? Would their genes be similar? Would their behavior be like ours? What implications is it going to have for religion? Because we only speak about religion here on Earth. We don't know what's going on if there's life on another planet. So it had all kinds of implications. Wook then discusses very briefly the shuttles. He calls them an engineering marvel at a far stretch of human ingenuity. The most complex machine ever built, its design, a web of innovation and compromise. So Columbia first went up in April 1981. Sorry, I thought I wouldn't cough today. That was followed by Discovery, okay? And then Challenger, which perished, if you remember, on January 28, 1986. Now, that made Feynman very, very famous, because he was called to the Commission of Inquiry as to why this crash took place. And he, in true Feynman style, he went to the hearing, and he had learnt that Challenger shouldn't have gone up because the temperature wasn't warm enough for it to go up. And what actually happened is that cold weather caused the old rings of rubber that were meant to seal joints on the spacecraft, helped them freeze. And when they froze, it crashed. So now, Feynman did the demonstration. he had a jug of ice water there, and he said, you look at these rings, and he plonked it into the jug, and he said, look at them now, aren't they a bit smaller? That was the cause of it. That was Feynman. And Wook says the chalk and blackboard man became better known to the public overnight than a lifetime of brilliant physics, plus the Nobel Prize, made him at 39 years of age. Okay? And then there was another shuttle crash, so 2 out of 5 shuttles disintegrated. And then, of course, there was this big debate in America. Can we afford it? We had the Manhattan Project. We made a bomb to beat the Germans. Then we had this NASA program to beat Soviets to the moon. Then Ronald Reagan comes along and says, I'm going to approve the superconducting super collider and a space station for NASA. And Bill Clinton comes along and he says, there's no money. Europe took over the collider, and they eventually built the Large Hadron Collider. So the International Space Station was helped by Japan, Canada, and Russia in terms of funding and expertise. So the Large Space Telescope eventually lifted into orbit by a shuttle, and it was christened the Hubble Telescope after Edwin Hubble. He was the man who first accurately measured the size of Feynman's big stage. Recently, you know about Cassini and these fabulous pictures that they sent us, all controlled from Earth. Even its crash on Saturn was controlled from here. That's how far science has brought us, ladies and gentlemen. And now they say we're heading for Mars. What that's going to do to our physiology, our anatomy, and everything else in our function, I don't know. Anyway, let's go back to Edwin Hubble. He had a 100-inch reflector at the Mount Wilson Observatory in California. Okay? And he measured what he called the redshift of the star's spectra, the light wave counterpart to the Doppler effect for sound waves. And he realized that the galaxies were moving away from us at a speed that was proportional to their distance from us. Those twice as far moved twice as fast. Actually, the universe is expanding. So, if it is expanding, it must have been at a single point sometime before it expanded. Now, Einstein didn't like this at all. He liked the idea of a static universe that wasn't expanding, wasn't contracting. But his equation showed that it can't expand or it can contract. And what he did, he went and introduced a cosmological constant to keep it static, and later called it the greatest error of my life. Hubble became a celebrity. He became a friend of Charlie Chaplin's, and he married Grace Hubble, who was a socialite, and she thought Einstein was a troll and an antique dwarf. Okay, so is the stage too big for the drama? Now, in the 1950s, these two gentlemen, Penzias and Wilson, they earned a Nobel Prize for finding the cosmic microwave background radiation. This faint residual radiant heat fits into Edwin Hubble's theory of an expanding universe the way a plug fits a socket, says Wook. Now, a reversal of Hubble's expanding universe takes us backwards in time to a point in cosmic history some 15 billion years ago, when the universe, in an instant cataclysm of radiation and heat, was there. So Hubble and Penzias and Wilson have now told us how old Feynman's big stage is, almost 15 billion years old. Okay? So Wook, as a non-scientist, saw it differently. He said, is there a hint in the cosmic microwave background radiation that a creator, the unnecessary hypothesis of Laplace and Crick, may stir after all? You see, he saw it from a religious point of view. So, he mentioned Laplace and Crick because when Napoleon commented that Laplace's great book, The System of the World, left out God, Laplace replied, I have no need for that hypothesis. And Francis Crick, the co-discoverer of DNA, asserted in his book that science was killing vitalism, the doctrine that the processes of life cannot be explained by chemistry and physics alone, and which Crick saw as a veiled vestige of religion in science, which had to be gotten rid of. Okay, so just the tribute to telescopes that Galileo Galilei in 1642, look at this, he died in 1642, and Newton, who was born in 1642, had telescopes. No theoretical boundary now remained to the brain's reach in space. And in modern times, other people, Hale, Henrietta Leavitt, who was a stone-deaf spinster, and this was a wow for women, because women were being brought into the science of cosmology, used telescopes to discover Cepheid variables of stars that blink. There were conferences were held. Einstein used to attend them. What is a star? What is a nebula? How old is the universe? Wook got tired of it. He said, let me come back home. Let me come back to Earth and see what science has done. I have an idea now of what science has done out there in the universe. But there is this place in our solar system where the basic ingredients that make up rocks and stones have been brought together in such a variety of form, function, and chemistry that just 1 gram of the resulting material exceeds in diversity all the matter found elsewhere in the known universe. And that is our Earth, our pale blue dot, our home, where diverse raw materials have come together to create living organisms. Okay? Now, Wook wondered a bit about these scientists, their arrogance, their overconfidence, how death certain they were. He looked at Feynman's life. Feynman used to go to nightclubs. He used to love the high life. Einstein, he didn't shy away from temptation. Hawking once said, I like Chinese women. And Hubble was a 6'2" Gary Cooper Copernicus with the accent and the look, even the tweed knickers of a Cotswold squire. And he was a fibber. So, the old one, Wook sits and he reflects upon this and he says, the old one, that means God, is amused that Homo sapiens, the species he created, convinced that in his outward bound quest, he is nearing the final truth as he runs and runs in the turning hamster wheel of eternal mystery. In the meantime, the universe quietly goes on doubling in time. God is an irony. He didn't like the way the scientists referred to God. Einstein referred to the altar, the old one. Feynman said calculus is the language God talks. Hawking says we will know the mind of God if we discover quantum gravity. I'll talk about that if I have a time. Darwin wrote of God in a religious mode. Darwin's was actually very interesting. As he became more and more familiar with his own theory, he began to question his religion. He was married to Anna Wedgwood of the Wedgwood family fame, and he when he began to have doubts, she became very worried. She said, are we going to meet in heaven if you go on like this? So Wook says this was not the God of Abraham or the Bible or Faraday's of Newton's. This God of the modern scientist is only a figure of speech, an ironic flourish. Okay, so Wook says how different a time we're living in now. He says when I was young and at Columbia as an undergraduate, I used to go to my grandfather who was a rabbi and sit with him and read the Torah in not in Hebrew, in Yiddish, right? And sometimes he used to say, Granddad, is it possible that Joshua stopped the sun and the moon? And the grandfather used to say, where are you going with your little paws? Right? And Wook now is silently posing the same question to his scientist friends, especially to Feynman. Where are you going with your little paws? Okay. Feynman eventually once said, in this book by James Gleick called Genius, The Life and Times of Richard Feynman, I was born not knowing and have only had a little time to change that here and there. That was a huge admission on his part. Okay? And then Wook had a nephew who was a neuroscientist who said, you know, Uncle, you're so clever, but why do you believe all this nonsense that there's a creator and who created the universe? And so Wook said to him, yes, you and your wife are professors, you're highly educated. Why do you want a bar mitzvah for your children? You're scared of something. So he goes back to Steven Weinberg, whom he liked. Weinberg, who made those two huge statements about the incomprehensibility and meaninglessness of the universe. He said Weinberg was a corollary with God in the vein of Job. God, on the available evidence, you are a figment. Okay? God, I am angry about the fanatic deeds done in your name, and I'm not interested in facile philosophizing to bring you back in existence. I can't blame you for humankind's misery because you do not exist. This is tragic, says Wook, because humankind gropes doggedly for the final truth, as in the book of Job and in Weinberg's writings. You see, Wook makes a connection. We're all human. You can't be dead sure of what you think you know through your science. And he wonders about Feynman, because in his lectures on science and religion, entitled The Meaning of It All, Feynman came close to articulating a personal faith, not in God, in humanism. Feynman never once mentions humanism, and another word he never mentioned was Judaism. How can it be? Our backgrounds are so similar. We had so much in common. And yet he avoided having a bar mitzvah and refused to repeat the Kaddish at his father's funeral. And scientists are human. They too, they might scorn us, religious people, but they're also scorned by their religious peers. Take Stanley Prusiner and the Prior. Prusiner said, this disease that we're seeing, called mad cow disease, or in sheep we call it scrapie, in humans we call it Creutzfeldt-Jakob disease. It's not caused by a virus, and he proved it. It's caused by a normal protein that you produce in your body, but which changes its shape. And he had a terrible time. The scientists didn't like that, because diseases were caused by bacteria and viruses, not by your own proteins. He eventually won, and he discovered a new biological principle of infection and won the Nobel Prize for it. Okay? So Wook says, science has an arbiter, and that arbiter is the peer review system, whose word is unchallengeable law. So as a scientist, if I made a breakthrough, I can't come here and tell you about it and everybody says, Mal made this breakthrough. I have to publish it. I have to first get it accepted for publication. And then the editor of a journal will send it out to experts. Read this and tell us, is this man talking nonsense, or has he got something? So it's a very, very tough peer review system. And this law, this unchallengeable law, is called nature in the humanist drama, and in the old traditional discourse, the creator. And Wook has faith in the scientific method, that all of Galileo, Bacon and Newton, of observation, of number and measure, which he called science, it has changed the life of man for the better, if with scary risks of terminal folly. Okay? So, the universe started 13.6 billion years ago with a Big Bang, and nothing much happens in the humanist drama for 11 billion years. That's Feynman's complaint. The peers cast back and talk astrophysics today. They talk chemistry, they talk cosmology, geology, paleontology to describe the barren period. They find fossils like Lucy, Australopithecus afarensis, that was found in Hadar in Ethiopia. And it was bipedal. It was one of the most complete fossil skeletons found. And it's dated to 3.3 million years. It might have vindicated Charles Darwin's theory of evolution. Should we believe the scientists, though? Why did they have Piltdown Man? Why are they so eager to tell us that they have the truth, and then they go and have a hoax like Piltdown Man? So, then there was the birth of the mind. And Wook asks us to imagine, what could have happened with these early beings, with these Australopithecines, with Homo habilis, with Homo erectus? One day, something dawned on some of them. They suddenly got up and they realized that they had a sense of self, the dawn of consciousness. What must it have felt like? Did they have language or didn't they have language? Oops, sorry, that's my phone. Okay? So the creature looks up from hunting or gathering food to watch the blinding, blazing hot ball overhead slowly across the blue dome and sink out of sight. I'm going to switch that off. And the creature wondered and was awed. The birth of the mind which can now grasp the Big Bang and take it all the way back to the first 3 minutes. Imagine, this consciousness made us conscious of the world and made us conscious of ourselves, the brain being a piece of meat that can think about itself. It's the most remarkable thing. I wish you'd jump up and down a little. So the great leap forward. So there is about 1.6 of a difference between the chimp and the human genome. And humans have language and consciousness. Now dinosaurs lived for 250 million years. We here for 200,000 years. Dinosaurs lived for 250 million years, and nothing left of those aeons upon aeons of wasted time but huge, horrid, long-toothed skeletons in museums and a bit of nightmarish fun in Hollywood blockbusters. It seems such a vastly drawn-out, complex, purposeless nonsense. He says not even a solid savant like Weinberg can believe that in his innermost soul. Weinberg might turn his face up and hurl defiance at the cosmos. Yes, I observe. Yes, I wonder. Yes, I'm awed, but not by you. For on the available evidence, you are not there. Why am I here? I cannot tell. Why it has all happened this way, dinosaurs and all, I cannot begin to tell. If I be damned, I be damned. Wook was wrong, in my opinion. There were scientists who were believers. Many of them. Isaac Newton. I know not what I seem to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself in now and then, finding a smoother pebble or a prettier shell, whilst the great ocean of truth lay all undiscovered before me. Now, Wook says these scientists, they accept Newton's incomparable stature, but they shrug off his piety. And even Feynman and Gell-Mann, when they lecture, they try and leave the religious part out. Okay? Now, so Newton gave us the laws of motion. He gave us the laws of gravity and the movement of planets. He gave us absolute time and space, amongst other things. Now, he was a classical physicist. Newton could know the state of particles that give rise to the big universe. He used this here, force is equal to this equation, force is equal to mass times acceleration. He could measure the velocity and the location of a particle. You apply a certain force to a particle of a certain mass, and away it accelerates. Since large systems, say of a gas, are just a collection of particles, he could use this to work out their behavior. If he knew the behavior of the very small, he could extrapolate it to the very big. And if he knew the state of these particles, he could make predictions about the state of the universe in the future. This was absolutely fantastic for that period. Right. So he gave us absolute time and absolute space, but he knew that none of these concepts could be directly observed. So his answer was, turn to God. The deity endures forever and is everywhere present, and by existing always and everywhere, he constitutes duration and space. And then this man comes along, Albert Einstein. Newton and the classical physicists were wrong. There is no such thing as absolute time and space. And he proved that by a thought experiment. He said, if I was standing on a platform at a station, can all of you hear me? No echo. Okay, I'm standing here at a platform at a station. I hope I get this right. Okay, my friend is in the middle of a train that's coming my way. Okay, there will come a point where that middle part of that train in which my friend is sitting she will be exactly in line with I am here, like you're sitting across from me. We are exactly in line, right? And say at that point, when that train is at that point, remember the train is moving, it's struck by lightning. It's struck by lightning, the front of the train and at the back of the train, right? And I stand here And because of the radius between me and the front and the back of the train are equal, I say, lightning struck this train exactly at 12 midnight. Right? My friend on the train, because the train is moving, will first be aware of the front strike and later be aware of the back strike. The time difference for my friend on the train will be a fraction of a second, but it won't be exactly my 12 o'clock. There's no absolute time, he said. I hope I got this right. I think I got it right. Have you got it right with you? There's no absolute time. It's relative, and who's right? Both of them are right. It's relative to the observer. This is how he formulated his theory of relativity. So, there is no such thing as absolute time or absolute space. He coined a new phrase, space-time. This is a new dimension. Okay? And his relativity, his special theory of relativity in 1905, I think it was, this is how he worked it out. Einstein made a thought experiment. So, here I am sitting in my house watching TV. I, like everybody else and everything else in the universe, am subjected to the laws of physics, right? There's a plane flying overhead, and my friend is in that plane. And she too is subjected to the law of physics. Now, I sit here and I say, I'm at complete rest. I'm not moving. Neither is my house. Nothing's moving. What is really moving is that plane that's flying overhead. Okay? In relation to my house. That plane is moving. The woman on the plane looks out and says, I'm not really moving. The earth is moving by. Not the plane is moving, I can't feel it. I can see the earth receding. Who's right? Both of them are right. It just depends on where you are. So everything is relative to the position of the observer. That was his special theory of relativity. Now, there is no way to determine which of them is in motion and which is at rest. The man in the armchair can consider himself at rest, and the plane in motion. The woman in the plane could consider herself at rest. Who's right? Both are right. Answer, each is moving relative to the other. Right. Now, then he formulated general relativity. Space-time are connected into a new dimension. Space and time are connected into a new dimension called space-time, right? Now, this is how I explain it. I'd rather not read this. If I move from point A to point B, I'm telling myself I'm moving in space-time, I accept that, but I'm moving in a straight line. Einstein says no. Space-time is actually curved. You can't feel it. It's curved, and the curvature of space-time is more when space-time comes near big objects like planets or galaxies. So this is how it's described. If that is the fabric of space-time, when it comes near planets, it actually curves. So we think we're living in a flat world or in a flat universe. We're not. It's a curved universe. Space-time is curved, and it's affected by big objects like the Earth. Now, then he told us about energy and mass. Mass and energy are different manifestations of the same thing. The mass of a body is a measure of its energy content. Energy equals mass times the square of the speed of light. This has enormous implications. This was the basis of the bomb. You had to only have a little material, and you could make a bomb. A kilogram of mass would convert into approximately 25 billion kilowatt hours of electricity. The energy in the mass of one raisin could supply most of New York City's energy needs for a day. Right? E is equal to mc squared. So Priyamvada Natarajan says Einstein's equations reveal that the contents of the entire universe, its geometry and its fate, were intricately linked. Knowledge of any two would permit the determination of the other. She wrote that in the New York Review of Books. But, ladies and gentlemen, there was a problem, right? The world of the very small seemed to be out of sync with the big world of Newton and Einstein. Although Einstein suspected that there was something. So let's talk about this German genius, Max Planck. There was a question that heat flows, people knew heat flows from hot bodies to cold bodies. So if I was very hot, my heat would flow around. That's why when you come into the room, all these hot bodies would actually pass their heat onto you and you'd feel a little warmer. Now, there was a question in science that the way that heat was released didn't quite gel with observed facts, because they thought that if you increase the temperature of the hot body, the heat will flow out in a continuous line, in a linear relationship, into the cold sink or into the outside environment. But that couldn't have been right, they said, because things can't just increase and increase and increase in temperature, and how far up can you go? So this man came along and he looked at the hot body, right? And he said, the only way we can explain this, and I'm being absolutely basic and simple here. Imagine heat leaving a hot body in the form of waves. We probably call it waves. Imagine you can take that wave and cut it into little bits. What he was saying is that the heat that leaves the hot body doesn't leave it in a continuous wave-like form. It leaves it in little packets called quanta. And if you explain it like that, then you can explain why a hot cup of coffee won't burn your tongue to cinders. Because the heat that is being released in a discontinuous way of various different wavelengths, not one continuous wavelength, a variety of different wavelengths, and so we can actually cope with that. Now, this was, when Einstein heard about it, he said, those quanta, those packets of energy, those are photons. Light can be both a wave and a photon or a particle. The most counterintuitive thing, and this is where the two-slit experiment comes in, that these photons can be both particles and waves, and they could be when they behave like waves, they can be in different places at one time. I know it's hard, but you will go and read this book and other books, and you'll grasp it. Okay, so in the quantum world, measurement becomes a problem. You see, Newton had force is equal to mass times acceleration, and he could measure anything. But now, how will you now measure the state of these particles that can also be waves? Measure the velocity, and you will not know the location. Measure the location, and it becomes impossible to measure the velocity. You can only talk in terms of probabilities. A wave or particle can be in two places at once. Perhaps it starts as a wave and ends as a particle. You can go back to the two-slit experiment and explain that. Funny thing is, if you watch it, it can change its behavior. Now science became very weird. The science of the very small, the subatomic realm, the realm or the world of very small particles. If you watch it, it could change its behavior. This caused so much grief for the scientists who were discovering this. If you interfere with one and the other, which could be very far away in response, that's saying that, if there are two photons that are together, they will have a different sort of orientation, right? And they will leave in those orientations and be far away from each other. But if you went there and turned the orientation of one, this one would change automatically here. Einstein was horrified. So just what on earth are you talking about? And what on earth are you doing to scientific objectivity? He called it spooky action at a distance. And he said, quantum physics, but Einstein hated it, but it works. Right from the transistor to the lasers to the internet. That's the world we have today, and it's through quantum physics, the principles of quantum physics. The universe was based on an uncertainty principle. And this, ladies and gentlemen, is the issue between religion and science. That religion has an absolute faith and dead certainty. Scientists say we can never really know. Einstein says, are you telling me God is playing dice with the universe? He started this idea, but he fought against it for the rest of his life. Okay? And then Hawking comes along and he says, so now we, in the standard model of physics and the 4 basic laws we have, we know the laws of the very small, the subatomic ray, but we can't unite it with the law of gravity. So if there is a unified theory, we'll call it quantum gravity, which should be understood by all scientists and philosophers and ordinary people. Then we can discuss why we and the universe exist. If we find the answer to that, it would be the ultimate triumph of human reason, for then we would know the mind of God. So, Wook says, I understand all this. I love Richard Feynman. He will never believe, and I believe. But Wook has come to a point where he can resolve this impasse. And he calls it the ghost light or the equity light. He says after a play, a stagehand plants a bright light on a pole on center stage. The rest of the house is dark. For Feynman, this bright ghost light in a dark theater was nothing but his own piercing mind, the spark of Adam in his genius brain, contemplating creation and finding it glorious but senseless. As for Wook, he sees a different ghost light, distinctly there, but very far off and hard to make out. It is not a single brilliant light like Feynman's intellect. It is an odd, flickering flame, like a tumbleweed or a low bush that has caught fire. Each time he looks, there it is burning. What Wook is trying to say is that sometimes my faith, like that light, weakens, and at other times it is strong, but it is always there. Okay? Now, I'm going to finish now, but Hawking just asks, he talks about the anthropic principle, and I spoke to you about those specific ratios. So people believe that those ratios or proportions between, say, a proton in the nucleus and an electron are exact, and if they were slightly different, this universe wouldn't have happened and we wouldn't have been here. He calls it the anthropic principle, and he says that this is how we look at it. Why did this universe happen the way it has happened so perfectly that we could be here? And that's the answer. It happened that way. So one day there would be a conscious being who can look at it and just simply marvel at it. Thank you very much. You're not allowed to ask questions. Please come tomorrow. What are we doing tomorrow? Well, are we doing science and the humanities tomorrow? Unification of knowledge. Thank you. Thank you. Thank you very much.